Hello, everybody, and welcome to the Autonomous Systems series. My name is Andre. I'm a postdoctoral researcher at Aalto University, and I will coordinate the event tonight. This event is kindly organized by Christina, Sarah, and Otto, and this event is brought to you by Aalto Center of Autonomous System. And today, we're talking about the marine application, and the first speaker is Mr. Roy Funck. He is the Senior Vice President of Technology at ABB Marine and Ports. His talk is about programmable vessels towards autonomous shipping. Humanity gradually evolves towards autonomous shipping. However, to optimize the task, some fundamental techno-economical topics must be addressed. These topics will be discussed today. A top-down view of drivers, capabilities and use case building towards a sustainable autonomous maritime will be given. And the second speaker is Professor Arto Visala, lead the Autonomous Systems Research Group at Aalto University. His main research interest covers autonomous systems and robotics, state estimation and sensor fusion, machine perception, and nonlinear modeling and control. His talk is about smart marine research at Aalto University, older and current topics. He will introduce both older and current research topics dedicated to autonomous ships. For instance, one of the running projects is Coastal Bots, an intelligent autonomous underwater multi-robot system for shallow sea monitoring and machine perception aided ice field analysis. Finally, technology for combined thruster and torque allocation towards operation at sea will be presented. Mr. Funck, now the screen is yours.
So the topic of today is kind of not very technical as such. It's more about looking at this gradual evolution towards these programmable vessels, as I call it, or autonomous vessels, or automation, higher automation vessels, depending on the audience or the receivers. And pretty much I will cover 3 topics, not in any particular order and not even kind of in a sequence, but they are all a little bit mixed together. So it's about that, what is the, first of all, the requirements as such for any meaningful maritime, autonomous maritime to be established? And what are the obstacles there, and what is the potential, let's say, evolution steps there? And I'm using a number of different kind of application examples of this kind of autonomous steps and this gradual evolution towards that one. And it will maybe be a little bit different than maybe somebody might expect, because I will not talk about any Star Trek type of autonomous vessel armadas like maybe some of our competitors have been doing in the past. It is more about let's say, much more pragmatic and what is really kind of doable and what is really happening, and how we see it that needs to be happened going forward and so forth. So by that, so I will start from the very, let's say, high level, but on the other hand, this one picture only pretty much sets up the scene in the way that the way the ships are operated today, they are actually pretty complex. They are pretty manual. They are pretty distributed, and the worst thing is that they typically, the operating systems, if you can call it that one, or the automation system and the navigation systems and the way you control the vessel, it's always a multi-vendor solution, and that multi-vendor solution is driven by cost. So the way these vessels are created, independently of how high-end cruise vessel it might be, or very low-end cargo vessel, it's always the same procedure that the vessel owner or the operator is asking for from different shipyards about offers, about how can you make a vessel like this one, and then the shipyards start to ask the manufacturer of equipment who can make the cheapest one, and the cheapest one is winning, and the interest of the owner is not really floating through that one, because at the end of the day, it's kind of very kind of biased, that the shipyards, they are literally looking at the cost side only, and they don't give a damn about that how useful that end product will be, because they are not selling the end product. They have just provided an offer for building something, and then they won the offer, and then they have a secured sale kind of. So the end result is that we have systems on board vessels that are not, let's say, in any way standardized, or they don't have any kind of meaningful interfaces. They are not working together. They are not sharing information. And even worse, they are kind of, if you have, like on this bridge, you can have multiple systems there, and they can, for instance, show the speed parameter in using or showing totally different numbers even, because depending on where that speed information is coming from. So this is kind of the starting point of the whole journey. Anyway, so there are some market drivers that is kind of driving towards more advanced vessels, and officially there are three market drivers. One being the energy efficiency and productivity in general. That is equal to solutions that is helping to move that heavy piece of metal smoother on the water, meaning that it can be moved with reduced amount of fuel burning, fuel usage, meaning that it can save money. That's the key driver in the whole thing. Or one result of reduced fuel consumption is the environmental topics. Like we most likely all know, there is an official target coming from International Maritime Organization, IMO, to reduce the CO2 emission by 50% compared to 2008 level by 2050. And that is just kind of a target that's not driving really anybody making investments. And then the third one is safety in general, because there are quite many kind of accidents caused by humans, and that has actually more influence for ship owners and shipyards to go forward than this environmental friendliness. Okay, then the kind of enablers to be able to do something. There are kind of three kind of key topics. First of all is this legislation related topics. So the maritime, particularly in talk about international rules, the maritime rules made by IMO has been written something like 50 years ago, and they don't even use the word autonomous in any way or places. Contradictory, they are kind of quite actually against the whole idea, if you can read it that way. I have an example of that one on the next slide actually. The other one is this business rationale. In order for somebody to be eager to pay more for a vessel that is, let's say, more smarter, there must be a business justification, and that business justification comes in form of cost saving one way or another. That's the only thing that drives it forward, and it's not that easy to actually find those cost savings. There are lots of different vessel segments, like this cruise and cargo and tugs and short distance, and the business impact is more meaningful in some of the segments and less meaningful in other ones. And that's far from straightforward. And then the third one is that a vessel must be electric, digital, and connected. And so it's quite difficult to even consider some autonomous vessel based on some two-stroke diesel engine with a direct shaft line, because that is simply not the way it can be done in a reliable way. But I will address these three topics now in a little bit more details, not too much, but a little bit. So first, about this registration point. There's kind of one example of this one is that the IMO regulation have a rule saying that a vessel who is operating on international water must have something called lookout function established. And that lookout function is defined as a human being, a person who is standing on the bridge looking out from the window and looking for surrounding objects somewhere, 24/7. That is stated in the regulations, and that already is kind of a little bit of a showstopper in some way, because in this case the human will be the sensor that is supposed to identify objects and then launch some kind of autonomous operations. But if he's there already, then does it make sense to build some smart kind of sensoring stuff next to him? That doesn't really work out that way. It's simply too expensive. And the other one is on the bottom of the slide. It is more compared to car industry. So in car industry, they have at least been able to define this kind of automation levels. So they have kind of six different levels of automation, and the car industry and the players and manufacturers and equipment vendors knows what it means when somebody is asking for level 3 lane assistance solution. Then the people know what to offer and what to install. On the marine side, there's nothing similar. There are lots of very bad kind of exercises done in this arena, but they all are pretty much useless as such. So and this leads to a situation that it's very difficult for anybody who would even like to buy something that is autonomous or higher automation level to know what to ask for. Because the ship is a big system of equipment and solutions, and if it's not defined that what does it mean to have a level 2 or 3 or 4, so it's very difficult to even offer something. Plus, because when those are not defined, then there's no standardization either in place. So it's kind of a little bit as a kind of, it's so different from car industry, because in car industry this is flying better, not because of a business case, because it doesn't make any sense whatsoever to buy a, let's say, high-end electrical autonomous cars like Tesla. Business-wise, it doesn't make any sense. They are selling based off because they are feeling that they are cool to have one, but that doesn't work in marine industry. It's not cool to have a vessel. It's a money-making machinery, and that must have totally different justifications. And also in the cars, they are made in tons of volumes. Here we are talking about prototypes. Every vessel still today are a prototype vessel. There are not two similar ones. Even sister series are different between each other. And then also the fundamental difference is also that if you compare to car industry that is always also very often used, it's a very bad comparison, because the environment where they are working is so different, and it starts from a simple situation where a car identifies some dangerous obstacles. Then the natural thing for the car to do is to stop. In a boat, that can be the most stupid thing to do, is to stop. And a good example is what happened 3 weeks ago with Viking Grace, when it stopped out south of Åland, Mariehamn, and it stopped. And by that one, the ship was not able to control itself any longer, and the wind pushed it towards the shoreline, and the LNG operation were not able to ramp up. So they are very different. So I just point it out because there's always comparison about why does it car industry go forward, but not vessels. There are reasons. But then on this slide, this is kind of just an example that what can be done for illustration point of view. So this is an example of something we did actually last summer. So what we did here is that we wanted to start changing this one simple regulation related to this lookout function. So we want to change the wording from a human being to something like a human or a system that is equally good or better than a human. And to get that process started, we wrote kind of a proposal, and for the proposal we made some sea trials, like the one on the corner where you can see this right-hand corner. That's myself sitting in my boat roughly 10 kilometers outside of Suomenlinna. And we were just simply using the video camera that is equipped on the Suomenlinna ferry, and we stream and store the data or the video, and then we run it through our AI-based image recognition algorithms, just to figure out that can we identify relatively small objects 10 kilometers away without having any zooming or any other purposes. And it was very easy to find. The reason why I stopped by this 10 kilometers was that when I tried to look backwards to see it, can I identify any kind of objects? I could not see anything at all, even though if I'm using all possible means. So this is kind of just kind of an example of that. Okay, it is easy to show that technological things can be better than a human, but to get the regulation moving, what needs to be done is that we need to go back to this IMO safety committee meeting that is happening in May, or starting in May next year, and we have our proposal to take on the table, and then it will most likely be taking as a step forward, and then after 4 to 5 years, the regulations can be changed for this particular topic. And this is so fundamental for all international traffic vessels that this very simple thing must be changed before we can really proceed for this kind of a more autonomous navigation type of stuff. And from Aalto, I think there's a good research topic here that I put a hint here that because now it says that we must be equally good as a human or better. So nobody has been so far able to identify how good is a human, because we are all different, plus we all operate differently depending on time of day and the situation we are. So to be able to justify a technical solution that is better or as good as human, somebody should first be able to identify how good actually is a human, and that can be dramatically actually bad in that sense. But anyway, so that is something that is kind of happening. Okay, then from this business rational point of view, as I said, that it's far from simple to say that does it make sense to aim for very high level automation or autonomous, or even try to, let's say, reduce the crew members by 50% or 90% or whatever. So this bar showing here on this picture is pretty much a breakout of the cost structure, cost components of operating a vessel. And if you talk about crew members only, then this blue area here is representing the cost of the crew. So of course, on this picture, it is maybe 5 to 10%. And if that can reduce by a highly expensive solution to half of it, yes, it has some impact, but it's not that magnificent. It's not in that magnitude that it will really make any big difference. But as I said, this is different from segment to segment. For instance, in this kind of big cargo vessels, and talking about container ships with 15,000 containers and a crew on a member of 10 people, does it really make sense to remove 2 or 3 of them? Because the cost is all about the fuel to move that chunk of steel. Or the cruise segment, the same thing there. There is maybe 10 people on the bridge. Then there is a big hotel with 400 people serving the guests. So again, if you can impact the bridge people with a couple of people in the total cost, it's nothing. Ferries, maybe something. Then in the short distance segment, that's a little bit different story. So then we're talking about these road ferries and this Suomenlinna ferry type of instances. There is maybe a potential, and it's kind of particularly in the street or road ferries, it's quite easy to justify just from the fact that when the current, let's say, personnel on those road ferries will retire, it's very difficult to find younger people who are willing to sit on those. So it is a real kind of a need to be replaced by something. So that is one domain where this can have a meaningful, in a big way, that we really talk about autonomous ship vessels. And then the safety, of course, is a topic that 70 to 80% of the accidents are caused by human errors. And that includes even quite modern US Navy ships who are able to drive right against a cargo vessel who is anchored in a daylight outside of Norway. And the reason for that one was simply that on that particular vessel, there were 3 guys on the bridge, because there are three control points, but none of the guys knew who is in charge of the vessel. So it was simply running towards other vessel that is standing still. But anyway, so said that, and these kind of start to be costly. So that is one driver that can have impact on more, let's say, smarter vessels, but not autonomous vessels, in the meaning that it will really be something that is just driving around there without anybody. Okay, if I look at then what is needed to be able to have this autonomous functionality. And now again, autonomous does not mean unmanned in this context. It's just more about that we are having autonomous kind of functionalities for different kind of situations. But anyway, so what is basically three things are needed, and this is equal to, for instance, car industry. We must have something that is able to sense the surrounding, measure distances, and detect objects and so forth. And this is typically cameras and lidars and radars and different kind of things that are able to scan around it and make some sense of that one. Then we need some more brains, that is, we are able to analyze that one. So we have a systems that are able to make some risk assessment of the situation. It knows where we are, what are the conditions, and what is the right way to address that one and make a decisions about, okay, it's time to go left and right or do something else. And then the third one is that we must be able then to make that execution of that decision in the correct manner. And this is kind of the very fundamental. And here we are now touching base with this, that what is autonomy and what is automation, because that is kind of not that easy to even define. And these terms are very nicely mixed together. And even that one is screaming for that. What I in the beginning said, that we need to have some kind of definitions about that. What are these levels, so it will be easy to people to understand what we're talking about. But nevertheless, so how we see that this is actually going now, if you look at from this kind of basic functionality point of view, situation awareness and control of the vessel movements and collision avoidance kind of solutions and so forth. So in this kind of bigger vessels, international going vessels, we've seen them they are getting some momentum as assisting solutions. So they are not replacing anything at all. They are just assisting. So giving guidance to the captain that, hey, now I think there's something going on. I think you should do something about it. But they don't even try to do something about it. They just inform the captain, and it's still the captain's job to make the decision, which is also one of the IMO regulation that is kind of saying clearly that there must be one captain who makes decisions. On the other, in local traffic, we are talking then about national traffic. Then this kind of registration is simpler, and for sure in the local traffic there might be very good areas where this kind of systems will be taken into use much faster. But then there is kind of a little bit question that in what kind of situations and how in general terms will be the acceptance of people of having that one. So talking about actually Suomen Lauta, so how many will like to go there if they will knew that there's nobody who is controlling that vessel on board, so or in the airplane at the same time, same simulation. So it's much about this kind of acceptance from that point of view. Okay, in the beginning I said that one obstacle is that the vessels are built in a way that it's a multi-vendor environment without any kind of standardization whatsoever. That means in practice that we have lots of functional products, engines and motors and automation systems and you name it, and they are all coming from different vendors. They don't talk to each other. They don't control each other. And on top of that one, we have control systems from multiple vendors. Again, they don't talk to each other. They don't control each other. And then we have different, the stack goes up and up. And one big obstacle for this whole thing is that there is very isolated systems. There's no integration between the systems. And that makes it very difficult for anybody to go forward in this respect. And even for if there will be a vessel owner who will really like to have something like this one, it will be very risky for him to make a movement and really have a single vendor lock-in situation. So if you compare this one to, for example, the mobile industry, I mean, they have been able to, over these 3GPP standardization forums for the last 20, 30 years, define everything. So it's very clear that very simple for any operator to just take out boxes from one vendor and replace them with other boxes from other vendors. They lose nothing. But here is a totally different thing that it's purpose made for one prototype vessel and it's not kind of operating together with anything else there. But anyway, these gradual steps, well, how we see it's moving, it's very simply that it has already started from this, let's say, asset level. So there are lots of solutions that are kind of looking at the assets and looking at the asset health and conditions, and they are helping to protect them and are forbidding for making operations that are kind of could be harmful for the asset in question. It be the propeller or propulsion, whatever. And the next level is this kind of a more advisory type of solutions, where we are talking about solutions that are helping the operation of the vessel to make it more, let's say, smoother, in a way that you can reduce all kind of rolling motions or improve this kind of energy efficiency by optimizing trims and so forth. And this is also already now, or has been already out there for the last 20 years, 15, 20 years. And then the third level is this fleet and terminal level, or fleet level. I just now leave the port side out and just the vessel. So the fleet level, so here we are talking about this kind of learning from other vessels and having this logistics chain operational in a way that we know where the vessels are when they come to harbors. We can prepare the ports for arrival and so forth. This is something that now starts to emerge, but it's not. But it's really in the first steps. And then the highest level here is this kind of a more autonomous vessels. And here one central function is the so-called virtualized bridge, as we call it, meaning that we should be able to come up with solutions that are able to remove the bridge from the vessel. So it's not, the bridge needs to be somewhere, but it doesn't need to be where it is today. So and what enables that one would be then a lots of technology that will take that one out there, and then when we have that one out from the place that's today, then that also enables remote operations and autonomous operations. But as far as it's kind of forced to be there and managed by people as it today, it's kind of a quite tricky thing. From this kind of a more or less this electrical digital connected point of view, so three very strong drivers are currently have been for a long time, but they are even more stronger than ever. And the first one is this decarbonization of shipping, which is a high level view here. But that means that all kinds of solutions that are helping to reduce the energy consumption. This will not help to get these 50% reductions, but this is helping in the level from 5 to 10% reduction of a fuel consumption, and the best way to get to this 50% reduction or more is to really have a look at alternative energy sources on the vessel. How can we produce the energy that is needed by the vessel on the vessel? And of course, we have fuel cells already today, and they are good for small vessels. But if you really talk about bigger ones, then the only technology out there is based on fusion power. And that is now under big debate now, that can that be accepted or not? And that is also a second topic that will be raised in the Maritime Safety Committee meeting in May next year. Then this programmable vessel, it's all about this advisory type of topics and how to help the captain to, let's say, trim the operation smoother. And the third one is more about this fleet learning and cloud-to-cloud sharing of data, so that you can learn from your sister vessels or learn from different captains how they operate the vessel, because there are huge differences about the usage profiles. And hence that one leads then to different kind of consumptions and cost levels. A few examples of this one. So this is now about this decarbonization. So the first one is from this icebreaker Polaris, where we have made some experiments. So icebreaker Polaris is an LNG-based icebreaker, the strongest one in Finland, and it's operating quite thick ice. And maybe you can see, but there's a blue curve showing the load profile, and that is kind of a very, very dynamic load profile. And having that one in combination with LNG is a nightmare solution, because LNG is not able to increase the torque very fast. So it results in a situation where these generators are running on very high speed all the time, because it must be prepared for the next big peak. And here we have installed actually batteries and fuel cells, and their purpose is not to drive the vessel, but it's just to do peak shaving. And that has already been able to show that it's between 10 to 16% fuel saving / emission saving by having a quite simple solution there. And this is actually quite huge result actually. The other one is this anti-roll, and what anti-roll means is it's a system software solution that is kind of reducing the amount of roll, so it's sidewise movement of the vessel, and that is done by changing the way the propeller is rotating, giving it kind of a pulses based on the weather condition, and those pulses will result in an unsmooth rotation movement, which will cause the vessel hull to lift from the water a bit, and that corrects the rolling motion. And by reducing the rolling motion, you increase the efficiency of the propeller. And again, we can achieve 1 to 3% with these kind of solutions. Doesn't sound much, but if you're talking about quite big fuel consumption anyway, so that ends up to a quite nice pile of money. Tow angle is very specific to Achipot vessels, but it is about us swiping around and finding the right angle of those propellers to be used so that the vessel is able to move forward as smooth as possible. And again, it's a couple of % saving, but still. And there are many others of this one. And these are all kind of going to that direction of autonomous or smarter vessels, but they are not, let's say, aiming for any unmanned operations. They are all about this saving of money. These other topics about this kind of a programmable side. So here this advisory is a very key thing. So it's a set of software-based solutions, AI-based solutions that are showing different kind of things that should be changed, like the trim of the vessel, or what is the right speed for this condition, or when to clean the hull, and so forth. It has to do with the passenger comfort, that where to go so that the vessel will not move too much or prevent containers to fall off the vessel, which happens way too often. It's a big stack of software, and there's lots of vessels out there which are using these ones. Then this maneuvering side, that is kind of very interesting, because here is kind of now we can compare to car again. Typically a car, if you really have even the latest Teslas, and the car is sitting in the parking garage, you cannot tell the car to drive to Tampere from Helsinki. It's not able to do that one. You can find it's easy to drive the car in autonomous mode, when you are on the highway between two white lines. It's a no-brainer to keep it there, but that is also has been the case for ships for tens of years. We can easily keep it on the planned route when we are out on the free waters. It's nothing new there. But then to get it that it's able to really maneuver in ports and do the mooring and so forth, that is a totally different story. And even going from the way that you really have a voyage plan made in the home office, and then you just send that voyage plan based on the cargo and directions to some systems on the vessel, and the vessel will take off and sail away. That will take quite some time, and I don't know what's the age of the people on this call, but I can say that we will all be retired before that is realism. That you can see a vessel of that side that is going from this voyage plan to the other side, just totally autonomous way. Then this third one, this Atlantis, that's happens to be an EU project that we are working on. So here we are simply that we have together created a solution that is helping the maintenance vessels to plan their routes and procedures in a way that is taking into account what they are there for and what is the conditions and so forth. So optimizing their routes and directions where they come to the windmill and so forth. And here we're actually quite close to the thing that it's a voyage plan to do something, and then we can give that voyage plan to the captain of that maintenance vessel. And if he really follows that one, then he is able to simulate being an autonomous driver, because he is then following just the pre-calculated, let's say, operations. I see my time start to get over, but maybe if I can 5 minutes more, I can try to ramp up it. This real marine ecosystem thinking. So here we are going for this very typical IoT type of thinking, or IoT or cloud device thinking. So for this to be true, we need to be able to have data sharing between different operators, different vessels, different harbors, ports, logistics chains, and so forth. And that is a very big thing to achieve, because people don't trust each other, people are not willing to share that one, and so forth. From pure technical point of view, it will be a no-brainer to be able to, for instance, to have a solutions where you can guide the vessels coming from New York to Rotterdam, to guide it about the right speed to be taken, so that it will arrive to the port of Rotterdam on just right time, not 2 days before, and hence driving way too fast and then standing 2 days there, but having the right speed, meaning saving fuel, and then arriving at the right time. But even that one is not possible as of today, because the data sharing is not there, and nobody has a control of that one. So that is yet another illustration type of topic that to be solved. But from I said, from pure, let's say, cloud point of view, it's a very typical cloud picture. I mean, this can be shown to all the way from mobile industry or to anybody at Microsoft or whatever. They have exactly the same Azure components, or as thinking that you have this kind of a data incorporation mechanisms where you somehow normalize this data and put it in some data structure, which is typically very industry specific models, and then you have all kinds of analytic tool benches and toolboxes and means to visualize that data and use that data, and then have a set of applications that are utilizing that data. There's nothing technically difficult here, except for the fact that to get this left-hand data sources somehow established so that people are willing to share that data, that is a biggest obstacle here. This example of actually one actual customer case we were working on for 1 year ago, and here was actually this kind of a taxi boats in Paris, and they wanted to have this automatic taxi boats going over the river Seine, and the basic thinking was that they want to have that people can either reserve that taxi, or the system will be smart enough that they are following how people are moving. So if there are bigger crowds coming towards the harbor, that is indication that, hey, people are soon needing some taxis. Or if there's some social media chatting ongoing that, hey, let's have a party on this or this place on that day, that indication, and so forth. So lots of kind of different kind of data sources leading to decision making about how to keep the flow of this kind of a small automatic taxi boats going. So this was the first kind of a real exercise where we tried to have some data sharing and similar in place, and in this case it was relatively easy, because the data source was pretty much the operators, and they are willing to provide this kind of location data, because they have that location data in their HLR databases already, based on the SIM data that we are carrying around. So this is in a small scale we can do this kind of a real kind of let's say programmable fleets. But unfortunately, this project never came to conclusion, because the customer get bankrupt, and that was the end of the story. I must jump over that one, or maybe just a few words about this one. So this is just indication that if you really go for this even one step forward from this, let's say, local traffic management towards a logistic management, where we really will be able to handle that when the factory has produced something, that will be then linked up with the local transportation, the trams, trucks, and whatever, and that will be kind of then linked to the ports, so they know what to do, where the crane should be, and that is kind of then going forward that the packing plans for the vessels are made, and the vessels are waiting ready, and they are then shipped out, and the same thing on the other side again. This will have a huge impact on the efficiency, cost, and CO2 emissions, because then nobody would wait anywhere. Everything will be kind of really smooth and nice. But again, technically wise, this is totally possible to do already today. But the problem comes that nobody in this chain of of players are willing to share any kind of data because they're afraid that somebody else can use it against them somehow, which is also true. Maybe I jumped to the very last slide, and as I see my half hour is over. So this is my last slide. So what I'll try to say here is that to go for this higher automation, autonomous, it's not a technical issue as such. Yes, there are technical topics, but we already know that everything that is seen can be solved. There are solutions that can be developed for that one. It's not a business decision either, because there are business reasons, but not necessarily strong enough in all places. And it's not only a legislation issue either, but it's actually a combination of all these ones. And we are now starting to tackle them piece by piece, but it will take lots of time, and that is where we are seeing this gradual evolution. And I will say, I can say that we are all the time improving the operational conditions on the vessels, on cruise ships and similar, but they are always this kind of advisory type of solutions. And there's no kind of intention whatsoever to aim for this kind of unmanned vessels that is going over without nobody on board and so forth. That will not happen, not this year, not next year, not after 20 years either. And that will not either happen in the car industry in a big scale, I will predict. There are cars that are carrying the family, but if you go then for bus or trains, or train could be easier, but buses or airplanes will not happen anytime soon. And with that, I think I will stop here because I used my time a little bit over.